Hi, today we are going to talk about different architecture types. The first one is monolithic architecture. Here, the client sends request to an application. This application is having UI component, business logic, and data access as a single unit. It is built as a single jar file and is deployed to application server. Application talks to database and sends response back to the client. Problem with this design is that it is highly tightly coupled. If any issue comes up in any of the single component, then the entire system needs to be redeveloped, rebuilt, and redeployed to the server. And if there is one single failure in any of the component, then entire system crashes. Right? Again, this sort of application is not much scalable. The next is layered architecture. Now here each component is built as a separate unit where web layer is HTML, CSS, or JSP pages. Application layer is built using EJB Enterprise Java Beans. Data access layer is built as JDBC API. And finally, we have database. Now, many enterprise apps and web applications are built using this sort of architecture during 2010, during 2000, right? Again, the issue with this design is that it remains tightly coupled even though it is structured in different layers. Next is client server architecture. For example, different email clients request data from the email server. All the required changes are done at one place, that is at the email server side. Another example is a DB client. This sort of architectures was used in 1990s to 2000. The problem here is this design highly depends on network connectivity and server can become issue, if it is not available as the system has a centralized control, right? And it highly depends on this one single server here, right? Next is point to point. In point to point architectures, we have each system uh, acting as a node and server and a client, right? So the control is decentralized. For example, the website which shares music files and provide an option to upload and download files to the user. Uh, it was used during 2000 and 2010. Here the issue is security and it's not maintained and it's complex to handle. And next is server oriented architecture. Here the idea is the application is developed as different services. For example, in student management system, we have student enrollment service, attendance service, entry management service. These services communicate via enterprise service bus. For example, TIPCO enterprise service bus. There is a better integration here across the application. Modularization is there. It was used during 2000 and 2015 to build large complex enterprise systems, for example, enterprise SAP system. The issue with this system is that it has extra overhead as an ESP component, right? It also uses SOAP WSTL heavyweight protocol, which relies on strict schemas, large XML message size, right? And it consumes more processing time. Now, the next is microservices architecture. In microservices, each service is built as a separate business service. It has its own components like database. It is deployed independently to cloud server. All these services communicate over HTTP protocol using REST standards. These are highly scalable services, and these are used since 2011. Amazon is built using microservices architecture. Netflix is built using such architecture. These systems need to handle data consistency and require appropriate design decisions. Right? Next is event-driven architecture. Here systems talk to each other by sending events and responding to events. Producers create the events or publish the events, and consumers react to these events or consume these events. Now, the message broker is there, which carries these events between producers and consumers. This type of system is used in real-time applications like a stock trading system. It's widely used nowadays. It's highly decoupled, scalable, and reliable, and is asynchronous. The last one is serverless FaaS, function as a service. So serverless does not mean that there are no servers. What it means is we do not how to manage the servers. For example, AWS Lambda is a function as a service. You write a function and AWS runs it for you. It is a cloud model where you just provide the function and the cloud provider handles the rest, right? And most importantly, you pay only for the time function runs. For example, students submit this form using HTTP POST request. Request hits Amazon API gateway, which authenticates the request and invokes AWS Lambda function. Function validates the input and saves records into MongoDB. Here there is no server management. It's very faster development, right? It is cost efficient and it scales with demand. One limitation is its initial delay, right? When a function is triggered after inactivity. And